Hello and welcome to the 12th in a series of films about the standard level organic topic. In the previous few films we've looked at functional groups that can contain oxygen, and here we're going to look at how we can convert some of those functional groups into others, in particular the alcohols and the oxidation reactions of alcohols. Okay, so we're going to start off by looking at the combustion of alcohols, so we're going to try and burn them and write equations. And then we're going to look at some other oxidizing agents that we might use and what they might turn our alcohols into, and how the conditions that we actually use for the reactions might influence the nature of the products that we form. Okay, so I'll start with, I suppose, what might be considered the simplest oxidation process, because it involves oxygen, so it's easy to see why it's called oxidation. It's becoming increasingly important to know about the combustion of alcohols, because we're trying to use them more and more as fuels, because we can produce them without relying on fossil fuels or non-renewable resources, so these can be a renewable fuel for us, hopefully. And just like with the hydrocarbons whose combustion we looked at before, what we need to know about complete combustion of alcohols is that it will produce carbon dioxide and water as the products. Okay, so writing the equations should really be quite a simple thing, so long as you know the formula of your alcohol and you can balance an equation. So here's ethanol, whose formula I could write as C2H5OH. It's going to be reacting with oxygen because this is a combustion reaction, and because it's complete combustion, that's the only type of combustion we need to be able to describe for alcohols, we're going to make carbon dioxide and water. How many carbon dioxides could I make? Well, I've got 2 carbon atoms here, so I could make 2 carbon dioxides. I've got 6 hydrogen atoms there, so I can make 3 water molecules. Now let's check out the oxygens. So I've got 7 oxygen atoms over here all together, so I need 7 from this side. And the most common thing to do is, or the most common mistake to make here, I should say, is to forget about that oxygen there. So if we include that one, we need another 6 from this side, and so the way to balance that is to add 3 oxygens. Okay, so these shouldn't be very difficult, particularly if we already know how to write combustion equations for hydrocarbons. Now, as I say, I mean, it's almost obvious that if you add oxygen to something, you're going to be oxidizing it. But some of the oxidizing agents that we use in organic chemistry, it's not quite so obvious that they should be oxidizing agents, so we need to remember some names. Okay, now the 2 most common ones that we're going to use are called acidified dichromate and acidified permanganate. The reason I've left these blanks here is because these are negative ions which you just can't get on their own. So most of the time you'll have sodium or potassium with these things. So it will usually be acidified sodium dichromate, or acidified potassium dichromate, or acidified potassium permanganate. Okay, so just be aware that when you see these things, dichromate and permanganate, we're talking about oxidizing agents, and they have to be acidified. So you might see like sulfuric acid being added as a reactant as well, but don't be thrown by that. It's just to make these things work. Now, if we're going to understand why these things are oxidizing agents and how these reactions that we're about to look at work, then it's useful if we've got a few different definitions of oxidation. As we've said, it could be adding oxygen. Another useful thing to look for if you're trying to see if oxidation has happened is if there's a loss of hydrogen. You can also talk about it as a loss of electrons, okay, but we're not going to look at it in those terms in this particular film. Okay, so let's look for a gain of oxygen or a loss of hydrogen as being a sign of oxidation taking place. Okay, so let's have a look at what happens if you oxidize primary alcohols. Remember in the previous film about alcohols, we said it's important that you can classify alcohols. Well, here's why: because primary alcohols react differently to other alcohols. If you take a primary alcohol and you oxidize it, so you add one of those oxidizing agents that we've just talked about, you can turn it first of all into an aldehyde, which would be called partial oxidation, because you haven't oxidized the molecule as far as it can possibly be oxidized. In fact, if you completely oxidize it, then you're going to turn it into a carboxylic acid. And I suppose it would be more accurate to say that the complete oxidation refers to an alcohol being turned all the way into a carboxylic acid. But what this kind of equation, if you want to call it that, shows is that if you partially oxidize it, you'll turn it into an aldehyde. If you oxidize an aldehyde further, you'll turn it into a carboxylic acid. So that suggests I would be able to turn an alcohol all the way into a carboxylic acid if I oxidized it completely. Okay, so that's an important thing to remember, that if you take a primary alcohol, you'll turn it into an aldehyde or a carboxylic acid. But very much depends on the conditions that you use. Okay, and if you want to make an aldehyde from an alcohol and you've mixed your alcohol with an oxidizing agent, then you want your aldehyde to escape from the reaction vessel as soon as it forms, because otherwise it's going to be in contact with that oxidizing agent and it will just get oxidized further to the carboxylic acid. So if you want to make the aldehyde from the alcohol, you would distill the product as it forms. Okay, because that will mean that you'll be removing your aldehyde as soon as you make it. Okay, if you want to turn your alcohol all the way into the carboxylic acid, then you need to carry out what is called a reflux process. Okay, and this is where any escaping vapors are basically condensed and they fall back into the reaction mixture. So any aldehyde that forms and tries to escape from your flask will condense, fall back in, come into contact with more oxidizing agent and be oxidized all the way to a carboxylic acid. Okay, as we've said before, these oxidizing agents don't work unless you add acid, so these will always take place in the presence of an acid catalyst. Okay, but the important thing to realize about whether you're going to make an aldehyde or a carboxylic acid is that it depends on the conditions that you use, and we need to know not really about how these things work, but the fact that if you distill your product as it forms, you'll make an aldehyde, and if you reflux your alcohol with your oxidizing agent, you're going to make a carboxylic acid. Okay, now those substances that we've looked at as oxidizing agents are have quite complicated formulae, and actually to write full equations with them is quite a complex process. So the nice thing is that when we're doing this, we've got the luxury of representing our oxidizing agent as simply oxygen in square brackets. Now then, if we're turning an alcohol into an aldehyde, I'm just going to take the simplest alcohol with just one carbon, okay, and we'll think about what we have to do to write the equation. Okay, so now we're going to turn it into the aldehyde, so that's going to look like this, and you can see here that we haven't gained any oxygen, but we have lost some hydrogen. Okay, in fact we've lost 2 hydrogens. So if we add an oxidizing agent, which is, remember, we're going to represent that as O in square brackets, if those 2 hydrogens now combine with that oxygen, then we're going to make water as our product. So in general, if you want to turn an alcohol into an aldehyde, add 1 oxidizing agent or 1 unit of it, and you'll form the aldehyde and water. If you're turning an alcohol straight into a carboxylic acid, then again, let's just take the simplest alcohol, although this carbon chain could be as long as I want. I'm going to have to add some oxidizing agent to it, but now I'm turning it into a carboxylic acid, so that would be that functional group instead of the alcohol now. The other part of the molecule hasn't changed. Okay, so now I have added oxygen, but I've also taken away 2 hydrogens, so I'm going to need 2 of these because I'm still going to make my water. So that needs 1 of the oxygens, and then the other oxygen comes from the oxidizing agent. Okay, so you can also imagine that if you take an aldehyde and turn it into a carboxylic acid, that this would simply require you to add an oxidizing agent, because the first oxidizing agent would make the water. You're going to make some water from, well, you're not going to make any water because you've already made it. Okay, so in other words, your aldehyde is simply going to gain an oxygen atom. Okay, so secondary alcohols now. The nice thing about these is that you can only oxidize them once, so it's a little bit simpler. If you're asked what will happen if you mix a secondary alcohol with an oxidizing agent, there is only one possibility, and that is that it will turn into a ketone, because you can't oxidize a ketone further. And once again, you might notice that what's happening to the actual molecule, well, you could say that where this functional group was, we're replacing it with this, and that involves the loss once again of 2 hydrogen atoms. So when it comes to writing the equations for this, let's take a secondary alcohol like, for example, propan-2-ol. Okay, so 3 carbons, lots of hydrogens which I'm not drawing in, an OH group up there. In fact, let's just draw this hydrogen here, just to highlight the fact that we're going to lose 2 hydrogens. Remember, I can represent my oxidizing agent as O in square brackets. I'm going to make a ketone, so this is going to turn into double bond O. So I'm now going to have CH3 on the end, that one there. I'm also going to have a C double bond O and a CH3 over here. You can see we've lost those 2 hydrogens. They're going to combine with that oxygen and make water. So there's a general equation for a secondary alcohol turning into a ketone. It looks very much like that first equation we saw on the previous couple of slides about aldehydes being formed from alcohols. How about oxidizing tertiary alcohols? Well, the good news about these is that they don't get oxidized at all. So if you're asked what products will form or to write an equation, well, you wouldn't get asked to write an equation. You wouldn't be able to form any products by oxidizing a tertiary alcohol because they're not oxidizable under the sort of conditions that we're talking about. Okay, so very important, obviously, that you can spot primary, secondary and tertiary alcohols, because if you then add oxidizing agents to them, then your products are going to be very different depending on not only what type of alcohol you've got, but if you had a primary alcohol, on what conditions you'd used. So quite a lot covered there, and in particular I kind of brushed over that last reaction where we turned aldehydes into carboxylic acids when we were looking at primary alcohols. So if you've got any questions about that, certainly come and see me as soon as you can, or post a comment on the YouTube channel. But what we should be able to do by now is to write equations not only for the combustion reactions of alcohols, but we also know what some oxidizing agents are that we could use to oxidize alcohols, and how the conditions that we use will affect the products that we form.